Chapter 13 Perceptron. In this section, I explain Perceptron, simplest architecture of an artificial neural network. A perceptron is a model that simulates the neural circuit of the human brain. This figure represents the structure of a perceptron. Perceptron converts inputs to output by weighting each input and outputting the result as 0 or 1. Each circle represents a neuron, also called a node. In this figure, there are two nodes in the left end. They take the information as inputs first. Then, they transmit the information to the next. Here, we have two nodes in the left end, but there can be more nodes, for instance, 3, 4, and more. Here, we have two inputs, x1 and x2. The inputs are variables that can take various values. The lines that connect nodes are called edges. Each edge has weights that are the strength of connection between these nodes and the next node. Let's call each node's weight as W1 and W2. Each weight works as a value that quantifies the impact of the input. The output is a binary variable, 0 or 1. The output value will be computed using the value of the inputs, weights, and bias. Bias is the value that adjusts the possibility of getting a 1 as the output. In the case of linear function, the bias corresponds to the intercept. As I noted, the output of a perceptron is computed using the values of the inputs, weights, and bias. Specifically, the output is the sum of each weighted input and bias. So, in this example, the output equals x1 by w1 plus x2 by w2 plus bias b. If the output value is smaller than or equal to the threshold, theta, the final output will be converted to 0. And if the output value exceeds theta, the final output will be converted to 1. Let's look at an example. Suppose the input to the first upper node is 0.4, and that to the lower node is 0.5. Each input is multiplied by the weights of each edge. And the bias is minus 0.8, and the threshold theta is 0.5. In this case, the sum of the weighted inputs and the bias is minus 0.2, so it is lower than the threshold. So, the output is 0. Let's look at another example. Suppose the inputs are 0.8 and 0.5, and the weights are 0.5 and 1.2. The bias is minus 0.2, and the threshold theta is 0.5. In this case, the sum of the weighted inputs and the bias is 0.8. It is larger than the threshold. So, the output is 1. What should be noted here is that, given input values, the output value of a perceptron depends on each node's weights and biases. In other words, we can change the output of a perceptron by just adjusting the weights and biases. The foundation of our brain function is a neural circuit that consists of many neurons complicatedly connected. A neural circuit processes information as continuous variables. On the other hand, A machine has a digital circuit that can process various information as a binary variable, 0 or 1. By dealing with various information as a binary variable, a digital circuit implements rapid information processing. A digital circuit uses a circuit called a logic gate for a logical operation. Basic types of logic gates are AND gate, OR gate, and NAND gate. In the following, we consider logic gates that has two inputs and one output. AND gate is a logic gate that outputs 1 only when both inputs are 1. Otherwise, AND gate outputs 0. The relationship between the input values and the output value is shown in the table, which is called a truth table. As we can see, only when both x1 and x2 are 1, the output y is 1. Otherwise, y is 0. When we construct an AND gate, we set the value of weights, biases, and a threshold so that the perceptron outputs 1 only when both x1 and x2 are 1. For simplicity, consider a case where bias equals 0. In this case, we can find a combination of the values of weight and the threshold infinitely. OR gate is a logic gate that outputs 1 when at least one of the inputs is 1. Otherwise, OR gate outputs 0. Specifically, OR gate outputs 0 only when both inputs are 0. As to OR gate, the relationship between the inputs and the output can be summarized as this truth table. Similar to AND gate, we can find a combination of the values of weight and threshold for OR gate infinitely. NAND gate is a logic gate that outputs 0 only when both inputs are 1. Otherwise, it outputs 1. That is, given inputs, the output of NAND gate is exact opposite to that of AND gate. As to NAND gate, the relationship between the inputs and the output can be summarized as this truth table. Similar to AND gate and OR gate, we can find a combination of the values of weight and threshold for NAND gate infinitely. Thank you for watching. Please thumbs up and subscribe to my channel.